In this lesson, we're going to graph linear inequalities. Example 1, how do I graph linear inequalities in slope-intercept form? All right, our first step is going to be to solve for y, if it's not already. Then we're going to graph it. You're going to determine if the line is solid or dashed. And we'll talk about that in just a second. And then we're going to determine if you shade up or shade down. All right, so if you have a solid line is going to be like when you have your closed dot when we graph the other inequalities. So we're going to have greater than or equal to or less than or equal to are going to be the inequalities where you're going to have the solid line. The dashed line is when you're going to have greater than or less than. It's like the open dot, all right? And then shading up, now this only works when you've solved for y. It's not going to work if you graph another way. Is if you've got the greater than, you're going to shade up, and if you've got the less than, you're going to shade below. So let's take a look here at this inequality. I'm going to start by solving for y. So y is, I just divided by a negative, so I had to flip my sign. Negative 4 plus 2 all over 3x. And remember when we graph using slope-intercept form, our slope here is a 2/3, and our y-intercept is our negative 4. All right, so I'm going to plot those 2 points here. So I'm starting at the negative 4, and from there I'm going to go up 2 over 3. All right, so now I've plotted those 2 points. Now I need to determine whether or not my line is going to be solid or if it's going to be dashed. Well, because I have the inequality sign greater than, that means that it is not including the things on the line, but it's going to be anything above it. I'm going to have a dashed line. And then, because I've got the greater, it's going to be shading up. All right. And tomorrow we'll learn another method. But today, if it's a greater than, you're shading up, and if it's a less than, you're shading below. And this only works if we've solved for y. All right, so let's graph the linear inequality. Number 1, we have y is greater than x minus 2. All right, it's already been solved for y, and my slope is going to be equal to 1, or 1 all over 1. My y-intercept is equal to negative 2. All right, so that means I'm going to start at the negative 2. And I'm going up 1 over 1. And now I have to determine if it's going to be shaded or dashed. Well, because I just have greater than, I'm going to have a dashed line. And then remember, greater than is going to be then shaded up. So any point that is in that shaded area will be a solution to this inequality. All right, question number 2. Notice how this one has not been solved for y. So we need to then get that y all by itself. So I'm going to add the 6x. Negative 2y is greater than or equal to 4 plus 6x. Now, remember we just divided by a negative, so we need to remember to flip our sign. All right, so our slope, negative 3 or negative 3 all over 1. Our y-intercept is negative 2. So we're going to start at the negative 2, and we're going down 3 over 1. Now, because I have less than or equal to, I need to then have a solid line. So I'm going to have a solid line coming down. And less than, so I have to go below the line. And sometimes you might have to turn your paper a little bit. And I'm going to then go below. One way, if you are questioning whether or not you're shading in the right direction, we're going to be doing this more tomorrow, but you could take a point 0, 0, which is right here. And let's check to see if that's a solution to it by just plugging it in. I could plug it into my original one, or so this is my x's, this is my y. If y is 0 and 0, is 0 less than or equal to negative 2 minus 0? Is 0 less than or equal to negative 2? No, it's not. And notice how I've shaded in the opposite direction. So if you're ever questioning, plug in the 0, 0, see if it's a solution. And if it is, shade in that direction. If it's not, shade in the opposite direction. All right, so we have y is greater than or equal to negative 3. All right, remember the y ones. In every case, y is negative 3. So in every case, I have 0, negative 3, I have 1, negative 3, I have 2, negative 3, and so forth. And now it's going to be a solid line because it's greater than or equal to, and I'm going to shade going up. All right, for number 4, we have x is less than 1. All right, let's remember that. So in every case, x is going to be 1. Remember, those are the ones that go straight up and down. So I have 1, 0, I have 1, 2, 1, 5, and so forth. And I'm going to have a dashed line because it's just less than. And now let's think about this one. This one we just know. Less than goes to the left. Greater than goes to the right. So we're going to, I know it's different than those other ones. We're going to shade going to the left. All right, so how do I write linear inequalities? Well, remember when we wrote these inequalities, remember we needed two things. We needed the slope and we needed a y-intercept. So let's identify both of those. Our slope looks like I'm going, here's 2 points. So I'm going down 2 over 3. Our y-intercept, where it crosses the y, is at 2. So we have y, and I'm not going to put my inequality sign there yet, negative 2 all over 3x plus 2. All right, now it's shading down, so I'm going to have less than, and it's a dashed line, so I don't have, it's just y is less than negative 2 all over 3x plus 2. All right, our next one. Again, you need two things to write the equation. I need our slope, and we need our y-intercept. Looks like our slope is 1. Our y-intercept is looks like negative 7. All right, so y, and then I've got 1x, or just x, minus 7. Now notice you're shading down again, and you have a solid line, so it's going to be also equal to it. All right, our last one over here then, remember these are the ones that go straight up and down. So this is an x. All right, and it's a solid line, and it's going to the right. So I'm going to have greater than or equal to, and that looks like negative 1. All right, so example 3, how do I solve and graph a real-world linear inequality? You have $50 in savings. You might need to change yours in your notes packet if it hasn't already been changed. You have $50 in savings at the beginning of the summer, and you decide you will save at least $10 a week during the summer. Write and graph the linear inequality that shows the possible amounts of money in your savings in terms of the number of weeks of summer vacation. All right. Let's make each of these worth 10, 20, 30, 40, 50. So here's my 50, and then 60, 70, 80, 90, 100. There's 100. And then we'll have the weeks go over by 1. All right. So we're going to have, we're started at 0 weeks. We had $50 in our savings. And then every week I'm going to have at least $10. So I'm going to go up at least $10 per week. So now I'm going to have this straight line that goes up this way. And so it's going to be up here. So after week 1, you will have at least you'll have at least $60 in your account, because here's our 160. But I could have more than that. If I put in more, than that, I would end up with, like, I could after 1 week, I could have $100 in savings if and so forth. So any of these solutions that you find in that shaded area could be the amount that you could have after that initial $50 that you put in. In this lesson, we took a look at how to graph linear inequalities using the slope-intercept form.